Welcome to the Predictive Analytics for Marketing course. My name is Dr. Ash Pahwa, and this is lesson 2. The title of this lesson is Data Central Tendencies and Variabilities. So in the previous lesson, we looked into what was data, variable, and samples. Now, in this lesson, which is lesson 2.2, we are going to discuss how we can display the data and also how we can summarize the data. This is the outline for this lesson. We will primarily focus on data plotting. In the previous lesson, we examined different types of data. We learned that we can have either the qualitative data or the quantitative data. Qualitative data is also called the categorical data. Now, with the categorical data, we can plot using the bar plot or a pie chart. And if we happen to have two different sets of categorical data, we can use side-by-side bar plots. Pie charts can also be created using this type of data. For the quantitative data, we can either plot a histogram or use stem and leaf plots. Quantitative data can be discrete or continuous. So we can have a histogram for discrete case as well as for the continuous case. If we have continuous data, we can also plot the stem and leaf, and we can also plot the cumulative frequency plots. So we are going to discuss all of these plots in this lesson. As you may recall, we had this slide in the previous lesson, and it basically describes different type of data, either qualitative or the quantitative data. Since this lesson is focused on plotting different data types, first let us quickly review all data types one more time. Qualitative data is also called the categorical data. If you want to divide that group further, we can have dichotomous, in which there are only two values such as present and absent, or alive or dead. Or we can have nominal. Nominal means that the data are unordered. As we saw in lesson 1, blood types would be nominal data, and the values it can assume would be A, B, AB, or O, because these are the blood types. If there are some particular order to the data, like we can rate some pain, it then in that case is going to become ordinal. Then on the quantitative side, our data can be discrete or continuous. With discrete data, it means that it can only assume certain types of values, whereas continuous means it can assume any value type. For example, discrete would be the total number of sick days per year. So this variable of sick days per year can only be integers. Now, in the case of a continuous data, it means it can have any value. So the goal of this lesson is to see how we can plot these different data types. First of all, let us start with the qualitative data, which is also called the categorical data. With categorical data, we plot this data on one axis, usually it is the x-axis, whereas the quantitative variable comprises the other axis, which is the y-axis. Now, since x is categorical data, what quantity value we can apply? These values could be either the count, which is also called the frequency, or the sum. It could also be any other kind of a matrix. So next we are going to see an example of this in a bar graph. Now let us look into this particular example. These data represent the number of surgeries which have been performed by an orthopedic doctor. This data shows the count of body parts operated upon. So this data is showing that back surgeries were 12, wrist surgeries were 2, elbow was 1, hip was 2, and so on. As you can see, the body parts comprise the categorical data because it divides the data into different categories, and the category name, of course, is the body part. And the second aspect here is a count, the number of surgeries that have been performed. This is our quantitative data. Now we are going to plot our data in a bar graph, which we will see in the next slide. Now we will plot the bar graph for the data that we saw in the previous slide. On the x-axis, we have the categorical data, which is a body part like back, wrist, elbow, etc. And on the y-axis, we have the count of surgeries. The bar of the category represents the count. The main advantage of a bar graph is that each bar represents the count graphically, which makes it easier to understand the data. The relative height of the bars for each category allows us to compare the count between the categories. Since the bar height for back surgeries is 6 times taller than the wrist surgeries, it makes it easier to understand the semantics of the numbers just by looking at a bar graph. We can also create another type of bar graph which plots the relative frequency instead of the count. A relative frequency is defined as count of an individual category divided by the sum of all categories. Now take the data in the first row of the table. The count of back surgeries were 12, and the sum of all the count is 30. Therefore, the relative frequency for back surgeries will be 12 divided by 30, which comes out to be 0.4. Similarly, we can compute the relative frequencies for all other categorical data. Now we can create another bar graph which plots the relative frequency instead of count. The shape of the bar graph for relative frequencies is identical to the shape of the bar graph for count. You can see both the bar graphs here. The count bar graph is on the left hand side and the bar graph for the relative frequency is on the right hand side. Since the shape of both the bar graph is the same, what is the advantage of creating a bar graph for relative frequency? The advantage is that the relative frequency bar graph also shows the probability of that event. And we add all the relative frequencies, it will add up to exactly 1. The relative frequency represents the probability of that event. Therefore, from this bar graph, we can conclude the following. Since the relative frequency for back surgeries is 0.4, it tells us there is 40% chance of that event happening. In other words, we can say that there is a 40% chance that the back surgeries will be performed. Therefore, relative frequencies allow us to compute the probability of that event. If we have two different metrics for our categorical variable, then we can use a side-by-side bar graph. So now let us look into this example. Our data shows the educational attainment of our sample. In 1990, 16,502 people achieved less than 9th grade, whereas in 2006 this number dropped to 11,742. This data also provides a comparison between 1990 and 2006. So the number of people who have graduated from 9th grade dropped from 16,000 to 11,000 during that period. We could also plot 9th grade through 12th grade, high school diplomas, some college, no degree, associate's degree, bachelor's degree, or a graduate degree, whatever we desire. So here is our bar graph, and it shows those counts which are being displayed right next to each other. By having two of these bar graphs right next to each other also shows the relative counts of these categories. We can also plot the relative frequency of this data. So how can we compute it? We do so by adding up all the values for 1990 and 2006 and then dividing the individual value with the sum total. So for less than 9th grade education, the 1990 is 16,502 divided by 158,870. So this number comes out to be 0.1039. Now we have computed these numbers, now we can plot them. we can see that the shape of the bar graph remains the same whether we display the count or we display the relative frequency. The only advantage we have when we display the relative frequency is that the value, the difference between them, is more reasonable. Now, if we look at the count for the high school diplomas, these numbers used to be 47,643 for 1990 and 16,898 for 2006. There was a huge difference. But if you look at the percentage or the relative frequencies, these numbers comes out to be 0.2999 and 0.03174. So now if we display it as a percentage of the total population, that increase is not as big as the one that we saw in the previous slide. So that is the advantage of displaying the data using the relative frequencies. The next type of chart that we can create is a pie chart. A pie chart is a very self-explanatory. We simply divide the circle into different pie-shaped objects, and the area of each of these objects represents the value that we have in our data. So let us revisit the same data we just used in our bar graph. We have only one metric here, and the categorical variable is educational attainment. We can see that less than 9th grade is being represented using blue. So in this pie chart, we can see how big areas are in relation to other areas. As you can see, the green one now contains the highest value and comprises the largest area, and it is the high school diploma category. So the pie chart allows us to see the relative values of each of the elements in our data. Now let us look into the next topic, how to plot our quantitative data. As you may recall, we can have two different types of quantitative data, discrete and continuous. So now first of all, let us look into the discrete numerical data. Before we plot these data, let us clarify the semantics. This particular table shows the number of arrivals at a restaurant within a 15-minute period. Let us examine this data in more detail. When the restaurant opens, 7 customers arrive in the first 15 minutes. During the next 15 minutes, 6 customers arrived. After that, another 6 arrived, and so on. Now there are total 40 observations which have been displayed in this table. If we sort these data, you can see that the same data in a table at the bottom of the slide. Now if you look into the sorted data, we see that number 1 appears once. So once in 15-minute period, only 1 customer came. And how many times did 2 customers came in the 15-minute period? So we can count the number of 2's, which are 1, 2, 3, 4, 5, and 6. So 6 15-minute period were there where only 2 customers came, and so on. So this provides us with the semantics of the data. Now we are going to plot a histogram. In this case, a histogram shows the frequency or the count of how many times such an event has happened. So now we see that in the 15 minutes period, how many times only 7 customers came. So if we count in this table and see how many times the number 7 appears, we will see that the number 7 appears 5 times. Similarly, we can plot this frequency data of all the values. So in the 15-minute time interval, how many times did only 1 customer arrive? This happened only once. Then how many times did only 2 customers arrive? It happened 6 times. So we can count the number of 2's in this table. We can generate these data which shows how many times certain number of customers have come to the restaurant. Once we compute this information, we can plot it. Now we can see the histogram, and also we can compute the relative frequency. Remember, a relative frequency is the frequency of the individual divided by the total. Now, if we add all these numbers up, that comes out to be 40. So, 1 divided by 40 would be the relative frequency of only one arrival. So, we can either plot the count or we can plot the relative frequency. The shape of the graph remains the same. As I said before, the advantage of plotting a relative frequency is that if we add all these numbers up, which are the relative frequencies, that comes out to be exactly 1. Therefore, relative frequency represents the probability of that event. In the previous slide, we saw the histogram when the bin size was 1. Bin size 1 means that we are only going to display each individual count in each bin. Now, suppose if we increase the bin size to 2, we want to find out the frequency when either 1 or 2 customers came within 15-minute period. So, now we are going to put 1s and 2s together. When we do the count, the total comes out to be 7, and that's what we are seeing in that histogram. Let us now combine 3 and 4. So, how many times 3s are there? There is 1 3s and there are 4 4s. So, the total comes out to be 5. That's what the next bar in the histogram is. If we change our bin size from 1 to 2, the shape of our histogram changes. Now, let us extend this idea and increase the bin size to 4. I would like to know how many times from 0 to 4 customers came in a 15-minute period. So, we can count all the 1s, all the 2s, and all the 3s, and all the 4s. So, as you can see, there is 1 1, there are 6 2s, that comes out to be 7, 1 3, that comes out to be 8, and there are 4 4s, this comes out to be 12. So, in this category of 0 to 4, now we have 12 customers. Similarly, we can count these things from 4 to 8 and then from 8 to 12. So, as you can see that if the bin size changes, then the shape of the histogram will change. Now, let us plot the quantitative data, but this time we are going to take a continuous case. In the previous example, as you recall that we were dealing only with a discrete case. So, now we will look into the continuous case. Let us start by examining the data that we are going to use in our example. These data show the 3-year rate of return of 40 separate mutual funds. Here we have 40 real numbers, and these numbers are 13.50, 13.16, 10.53, and so on. Now, if you want, we can sort these data and then look into what kind of a distribution we get. As you can see, when we sort it, the lowest number comes out to be 10.06. Then we have 10.53, 10.57, and so on. So, now we will plot a histogram of these data. Now, we are going to plot a histogram of these data. That means we are going to plot the frequency of how many times some kind of a data occurs. To plot a histogram, we need to decide what the bin size will be. Let us assume that our bin size is 2. We need to find out how many times of values are between 10 and 12. So, you can see the sorted data we have includes of 10.06, 10.53, 10.57, 10.99, 11.32, and 11.34. So, these 6 values fall between 10 and 12. So, now we can plot this histogram which will display these values. Similarly, we can count the number of values between 12 and 14, between 14 and 16, between 16 and 18, and so on and on for this histogram. Remember, our bin size is 2. Of course, if we change the bin size, the shape of the histogram is going to change, and we will see that in the next slide. For now, let us look into the relative frequency. As you may recall, when we were discussing the bar graph, we also looked into the relative frequency and learned that this concept of frequency of a particular item divided by the total number of frequencies. Since the total value here is 40, if we need to compute the relative frequency of the number of the data between 10 and 12, which is 6, it will be 6 divided by 40. So that is a number that we display as the relative frequency. So as I said before, the main advantage of showing the relative frequency is that if we add all these relative frequencies, they will come out to be exactly 1. So the relative frequencies represent the probability. Now let us plot a different histogram of the same data, but this time we are going to change the bin size. Let us decide our bin size is 4. We will be displaying all the values which are between 10 and 14. As you can see, if we count numbers between 10 and 14, the total comes out to be 20. And between 14 and 18, there will be 15 values and so on. Also, by changing our bin size from 4 to 1, the shape of the histogram changes. So the shape of our histogram is a function of bin size. Now let us look into the stem and leaf plot. It is used to display the continuous numerical data. So let us explore this next. Our stem and leaf plot are similar to the histogram. So here we will be plotting the frequencies of the data. Here again we are going to use the same data as before. Here we have the rate of return of 40 different mutual funds, and these numbers vary, as you can see, from 13.50, 13.16 and so on. One of the best ways to see this data is to sort it out. This will enable us to draw the stem and leaf plot. In the stem and leaf plot, we take the number before the decimal point and then take number which comes after the decimal point. So now you can see that for the first three numbers, we have 10.06, 10.53 and 10.57. Because 10.06 rounds up to 10.1, we display 10 on the left side of that vertical line, followed by 1, which is after that vertical line. The next number is 10.53, which is rounded down to 10.5. So we will be using 5 now. So we have this bin of only size 1. So this 5 of 10.5 appears next. And now the third number is 10.57. This will round up to 10.6. So we are only going to use the 6th part of it. So in this bin size of 1, now we have 10 on the left side of the vertical line. Then after that we have 1, 5 and 6. Now after that we have 10.99, which comes out to be 11. So and then 11 of course comes out to be 11 and 0. So this is how we plot these numbers. On the left hand side, those numbers that are after the bar or after the vertical line comes out to be those numbers which are after the decimal point. The advantage of plotting a stem and leaf graph is that you can see the distribution just like histogram. So this is another way by which we can plot a histogram, and you can see that the stem and leaf plot that we have plotted here looks very similar to the histogram of bin size 1 that we created before. Now let us look into the cumulative frequency distribution plot. These are derived from the histogram. This is a different type of histogram. Here we not only compute the frequency but also the cumulative frequency as well. And now we will be looking at the histogram, and as you may recall, we saw this particular slide just a few minutes back. I would like to point out here that we are not only going to plot the frequency but also the cumulative frequencies. So as you can see, if we have the value from 10 to 12, that comes out to be 6, and 12 to 14, the total value is 14. So the cumulative value is going to be 6 plus 14. That comes out to be 20 and so on and on. So we will compute the cumulative values in the next slide. Now we'll be looking at the cumulative frequency. So these data represent the same thing that we had in the previous slide. The only thing that has been added here is a cumulative frequency. So now let us explore this. First of all, we will compute the relative frequency we have already seen. So the cumulative frequency will become the sum of all the individual frequencies from the beginning. So for bin number 1, which is from 10 to 11.99, the relative frequency is 0.15. So the cumulative frequency is also 0.15. Now for the next item, which is bin number 2, from 12 to 13.99, my relative frequency is 0.35. So the cumulative frequency will become 0.15 of the previous bin plus 0.35, and that comes out to be 0.50. So the 0.50 number tells us that there are 50% of the values which are less than 13.99. To verify that, we can see that there are 20 values out of 40 which are less than 13.99. Therefore, cumulative frequencies represent the percentile rank of that data. In the case of a cumulative frequency, when we reach at the end of our list, we should reach at 1. This is our proof that our math has been done correctly. So as you can see, now our cumulative frequency is indeed 1 in the last bin. So now we can begin to plot the cumulative frequency. So as you can see that if we start from 0.15, then we jump to 0.50, 0.75, 0.85, 0.925, and 0.925. And then finally we reach 1. We can see that how fast this particular graph is growing and shows the number of observations that we have in this particular segment of the data. The cumulative frequency of a point tells us how many percentage of the values are equal to or less than that given point. So this is the end of lesson 2. To recap, we looked into how we can plot the data. First of all, we looked into plotting the qualitative data, which is the categorical data, and we can do that thing using the bar plots. If we have two different metrics related to the sum categorical data, we can also plot side-by-side plots. We can also have a pie chart of a categorical data. Each of these graphs has its own advantages and also own disadvantages. These kind of plots are used very heavily in statistics. Then we looked into how to plot a quantitative data, build a histogram, and generate the stem and leaf plot. As we now understand, the quantitative data can be discrete or it can be continuous. So in both cases, we can have a histogram. For the continuous case, we saw how to generate the stem and leaf plots. In the end, we looked into the cumulative frequency plots. The cumulative frequency of a point tells us that how many percentage of the values are equal to or less than that given point value. Thank you. I will rejoin you for lesson 3.